All right, today we're going to be doing some conditional statements. We're going to start off with some logic. And we're going to be taking a small break from some numbers, and we're going to be going to some sentences and creating some statements. This is the second section, the second unit, and the first section of that. Here we go. Let's get started. All right, you have some paper folding notes that were handed to you to use, and we got started with conditional statements was the first one that you used. There are two parts to conditional statements. There is a hypothesis, and it's labeled with the letter P, and we have a conclusion, and it's labeled with the letter Q. I'm not quite sure why they picked P and Q. It could be there could be a Latin word for it. I'm not quite sure. But the P and the Q, the P is for hypothesis, Q is for conclusion. A conditional statement is in the form of if-then. If comes first, then comes second. The if portion of the statement is the hypothesis. There will be a comma, then section will be the conclusion. Here is a statement. If it is noon in Georgia, then it is 9 a.m. in California. The red portion and the purple portion, the colors coincide with our red and purple up here. The red being the hypothesis and the purple being the conclusion. If portion being the hypothesis, the then part being the conclusion. All right, we're going to do some examples. You do not have to write this down unless you absolutely think you need to. All right? So if I gave you a statement, you will turn the statement into a conditional statement. So if I said, all sharks have a boneless skeleton, can you tell me what you would turn that into an if-then?
I got if.
If, go ahead, Amy, tell me if.
If all sharks have a boneless skeleton, then
No, that's not the if part. Try one more time. Somebody else try.
Oh,
if
wait.
all sharks have a skeleton.
No. If what? I'm going to put the word it. If it. If an animal.
If
If it is a shark, then it has a
boneless
boneless skeleton. So, or we could say if an animal is a shark, then it has a boneless skeleton. So you might have to add some words in there to get it to work. All right, here's an example of one. If an animal is a shark, comma, then it has a boneless skeleton. All right, you could write that down or you don't have to. It's up to you. All right, here's another one. Actually, wait. No. You have a statement in your notes. We already did write that as a conditional. We already did that, so no stress. All right. You had when it is noon in Georgia, then it is 9 in California, and you wrote, what did you write?
Oh.
If it is noon in
Georgia,
Then
it
is 9 in California. And if you wanted to put the little AM, you could have. You didn't have to. All right. There are some symbols we can use. Mathematicians don't like to write things. They want to have X's and Y's and pluses. They don't want to write the word P-L-U-S. They want to write a symbol. All right? So the P and the Q symbols that we use, when we're writing an if-then statement, we can write it like this. P implies Q, or this means if P, then Q. There's a spot for that in under the flap there, under your folding thing. It's right at the top. It says if P then Q. If P then Q, you can write P arrow Q. That's not how we say it. That's how you'll draw it. This is the mathematician way of saying if P then Q. If P then Q. Right? Like I said, mathematicians, they want to get their point across now, and they don't want to have to write a bunch of stuff. They want to write symbols that mean sentences. Because if their things are like a wall long, they want to do it quickly. Usually mathematicians' brains work really fast, and if they have to write all that stuff out, it takes forever.
I'm so glad.
All right, now we're going to do something called the converse. You should see that right next door under on your notes there. A conditional statement that switches the hypothesis and the conclusion. Okay? So if you flip up that flap, that's you have little places to put that. A conditional statement switches the hypothesis and the conclusion. You can fill in the blanks for that. We're going to do some examples of that in a moment. It switches the hypothesis and the conclusion. Here's an example. So if you see lightning, then you hear thunder. The hypothesis for this one is if you see lightning, then you hear thunder. You will always have the if at the beginning and the then, but we will be switching the you see lightning and the you hear thunder. We will be switching it around. So it will look like this. If you, the converse would be, if you hear thunder, then you see lightning. All right? I want to caution you, the converse is not always a true statement. All right? Yes.
Does it matter if you change the words like see to stop?
No, it does not matter if you change the tense of the sentence. You can have it present tense or past tense. It doesn't matter. Okay? They're doing it because you have to have seen the lightning before the thunder because of the way it goes. Yes. All right? All right, here we go. The one on your paper. You have been writing about Georgia and about California. I want you to now write the converse, and we'll talk about it. See if you can figure out how to write the converse of if it is noon in Georgia, then it is 9 in California. I want you to write the converse for that. You're going to flip the hypothesis and the conclusion. This is what I got when it is noon in Georgia. Actually, that's what it was, right? And then the converse would be what you had the other way. We said it was if it is 9 in California, then it is noon in Georgia. The symbols with the P and Q for converse, you're going to have, since we're swishing it around, and the converse was the Q, and the hypothesis was the P, we're going to have this symbol for converse. It's going to be Q implies P. Or if P, Q, then P. Questions? There's a place for that underneath that converse spot. Okay, so where are we going next? We did conditional statement, converse. Where are we going next?
Negation.
Negation, okay. On the word negation, you should be able to kind of, is there a mathematical term that's inside there that you can see? Or at least the root of it? Negative, okay, exactly right. It has the same root as negative. So that's hopefully going to help you to remember it. A statement can be altered by negation by writing the negative of a statement. Here's an example. Angle A is 30 degrees. You don't have to write this down, but you can if you want, okay? Actually, you will, right, because there's a fill in the blank for that. If I was going to negate this, and angle A is 30 degrees, I would say it like this. Angle A is not 30 degrees. And so I will put a not, or a word that means not in the, most of the time you're going to use the word not. Okay? So the negation symbol looks like this. It's a tilde. You want to say it in Spanish? It's a little curvy thing. So to negate something, if this was a P, the negation would be not P. Okay? The original, we put a not in front. Okay? So your symbol is a tilde. Or the squiggle. You're going to need negation to do the other ones. Most of the time I won't ask you to negate something, but we needed to know negation to do the next thing, which is the inverse. Is that correct? Yes, inverse.
Yes.
All right, so we have to have this to do the inverse. So the inverse makes the hypothesis and conclusion negative. So we're going to use that original statement that we had and just negate or put a not in both the hypothesis and the conclusion. Let me show you an example after you've filled in your blanks. Making the hypothesis and conclusion negative. Here's an example. Here's a conditional statement. If angle A is 30 degrees, then angle A is acute. We're going to slip some knots in there. We're going to put a knot in the hypothesis and the conclusion. Here is the inverse. Here's the inverse. It says that angle A is not 30 degrees, and if angle A is not 30 degrees, then angle A is not acute. That would be the inverse of that statement. You can write this down if you need to. You don't have to. I'll give you space in a moment to do our Georgia, California thing. Okay? All right, so in yours, we had a statement at the very beginning. When it is noon in Georgia, then it's 9 in California. We made this the if on the front. We made the then. I want now you to write the inverse. And we'll talk about it in a minute. Symbols, I keep getting ahead of myself. We're going to do the symbols for inverse. Does anybody have an idea about what we're going to do for the symbols for that? We're going to have
P.
Yes.
Not P.
Yes, we're going to have a not P.
Implies not.
Implies, very good, not Q. All right. Now we're going to talk about the contrapositive. By the way, just because the conditional statement was true does not always mean that the inverse is true. I just want you to, all right, so when you're going to be doing some of these for your homework, do not worry if what you're writing is a false statement. I don't care if we're doing true or false. I want you to practice doing inverse, converse conditional statements. Okay? Contrapositive. The contrapositive. The contrapositive. This is the negated converse. This is a mixture of both the inverse and the converse. The inverse and the converse mixed together. So we're not only we're gonna flip the P and the Q, or the hypothesis conclusion, and we're gonna knot it. So here's an example. The one we had a minute ago. If angle A is 30 degrees, then angle A is acute. I am going to flip the acute and the 30 degrees around, and I'm going to put a knot in there. So this is what it's going to look like. I'm going to pause for just a minute because you guys are so... Oh, this one right here, I'm going to have if what? If angle A is not
30 degrees.
Acute.
Not acute. Because remember, we're flipping this one, the acute side over. So we're bringing that one to this side. If angle A is not acute, then angle A is
It's
not 30 degrees. Is that a true statement?
Yes.
This one might be true. If angle A is 30 degrees, then it's not acute. Wait, is that true? Is that true?
Then it is acute.
It is acute. This is true. All right, but this is the contrapositive true. Let's just analyze this. If angle A is not acute, then it's not 30 degrees. Is that a true statement?
Yes.
Yeah.
If you put yes, that is.
Yeah.
So what if I said, give me an angle that's not acute?
90, like 91.
91. Okay, so 91. If it's 91, which is not acute, does that mean it's not 30 degrees?
Yes.
That's true, because it can't be 30 degrees if it's not acute. So this is a true statement also.
Yes.
Okay. All right. If it is there's the contrapositive.
Now, if you had the inverse of that, or not the inverse, but just negating it is not.
So if I would have done this one on the last one when we did the
inverse,
the inverse, was it true? The inverse was just if it's not 30 degrees, then it's not acute.
which is wrong.
That's not true.
That's not true.
Because if we would have had 45, it still could have been acute. All right. Here we go. We did the one on your paper already because you guys were so great and did it ahead. Let's talk about the symbols. We did that already, the symbols. Now, we said not has the tilde. So how will I write my symbols for this? Not what?
Not Q.
Not
P.
Q.
Not Q implies not P. Good job. All right. We now have the last one. It's called biconditional. We're going to see biconditionals when we're going to do postulates in the future, okay? There is a symbol to help us go faster with this one too, because again, mathematicians don't like to write a lot. A biconditional is a special conditional statement. It's a way, the way it is written, you have the original and the converse all wrapped up into one statement. So it is the original and the converse together. Okay? And it has the words if and only if inside. This is the one that has the special symbol. I'll write it now, but I might come back to it in a minute. Mathematicians don't like to have to write if and only if a whole bunch of times, so they write IFF. That is the mathematician way of writing if and only if. You can abbreviate. I personally love to abbreviate. If and only if, and it might even be capital. I can't remember. I don't think it really matters, but I've seen it more likely capitalized.
So
When
that was what you is that what we would write?
Yes, that's what you'll write there. Oh, but you can write that too. I forgot about that.
Okay.
You can also write that too. I'll bring it up in a minute when we get there, okay? I bring that up there too. There's also the triple. I don't know if you'd call it triple equal because it's not really triple equal.
Underlined
but
equal sign.
An underlined equal sign. There we go. You can also write that for if and only if. But that would be with your P and Q parts. If you have to write a whole sentence out, I'm going to actually be having you write out sentences. You're going to write the sentence out. If you don't want to write the words if and only if, and you want to write IFF, you can do that. This
So
symbol
you can't use that in a sentence?
That's right. You'll write. This would be if I was asking you to tell you about the P's and the Q's. Okay.
So technically, if you're in her logic class that they were doing at CC, then you could use it.
You could have read the if the IFF if you want to. All right, here we go. Let's do one. Oh, there's the IFF and there's the if and only if. Bring it up again. Here's an example, okay? Points are collinear if and only if they lie on the same line. Okay? This is two statements wrapped up in one. This is if points are collinear, then they lie on the same line. And the converse, if points lay on the same line, then they're collinear. So this is two statements wrapped into one, and it is telling you, as a mathematician, that the conditional and its converse are true. I told you before that the original and the converse are not always true, but if you see an if and only if in there, both the converse and the original are both true. Okay? In geometry, at least. Okay? I can't speak for the rest of the logic world, but for geometry, I can. So if when we go along throughout the school year, you will see the word if and only if, and this will imply that both backwards and forwards are true. So the one in your notes, is the converse of the one in our notes true? Is it true that if it's 9 a.m. in California, it'll be noon in Georgia? Okay, so the converse was true and the original was true, so we can write a biconditional for it. So what would we write? Anybody have one?
If and only if it's noon in Georgia.
We don't start off with if and only. Notice that the if and only if is in the
yeah.
center.
It is noon in Georgia, if and only if it is 9 a.m. in California.
Yes, so we start off with one of them being in front. And you know what? You could have done it the other way around. You could have said, it is 9 a.m. in California if and only if it is noon in Georgia. You can have because they're both true, both directions. If you would have been correct to write it both ways. All right. Let's talk about the symbols. With the P and Q, there's two ways you could be writing this. You could do P, IFF, Q, or you could do it that other way with your your underlined equals. There we go. Okay, that also means if and only if. I tried to consolidate your notes and you watching so we didn't have so much to write, but you had a way to refer back. For me, the hard part of this stuff isn't taking a statement and rewriting it. For me, is remembering, is inverse just flipping, or is that the one with the negative in it? And so for me, remembering which one goes with which is the harder one. So especially inverse and converse. Contrapositive for some reason, I just know you do both for some reason. It's longer. So it's the inverse and the converse that give me a little trouble. So this will be, you'll be able to flip those over and quiz yourself with your notes and to try to help yourself remember.